Hello everyone, I'm going to present you a demonstration about the testbed for time-slotted LoRa communication we have created at Tyndall National Institute in Cork, Ireland. I presume you know what time-slotted communication is and what LoRa and LoRaWAN is, so I'm going straight forward to the testbed. So this testbed consists of 25 PICOM low Pi 4 nodes like that one, and multiple single channel gateways for join requests, data, acknowledgement, and statistics. One of the reasons we're using single channel gateways is for the sake of cost and simplicity, but there is another reason that I'm going to explain you in a while. But anyway, depending on what we want to implement on this testbed, multi-channel gateways can be added as well. Currently on the testbed is implemented TS LoRa protocol. It's a collision-free and autonomous time-slotted protocol which bases its operation on LoRaWAN registration mechanism, the over-the-air mechanism of LoRaWAN. So if you're familiar with LoRaWAN, you know that when a node wants to join, a network sends out this information to the gateway, the network server, and then the network server responds with some with a join accept message, which contains, among others, the device address. So in this protocol, we manipulate the device address so we can easily extract the slot number, which is unique for each node in the network, so we don't have collisions. But in any case, if you want to know more about this protocol, just check this publication here. So in this testbed, we follow a multiple parallel frame structure where we have multiple frames and one frame per spreading factor. Here in this example, we have spreading factor 7 and spreading factor 8. So we have two nodes accommodated in spreading factor 7 frame A and B, and one node C accommodated in spreading factor 8. In the end of each frame we have a SAC slot. This is a special slot which is used by the gateways to let the nodes know if their packets were received or not, and also for synchronization purposes. So this testbed consists, as I told you, of 25 nodes plus some gateways. We have the Raspberry Pi here, which serves as the network server in LoRaWAN, and is connected using Wi-Fi to one or more gateways. So the nodes, when we want to register, when an experiment is initiated by Raspberry Pi, they send their request to the gateway here, and this gateway communicates with the Raspberry Pi, and it generates the slot, and it gets the device address actually, and this gets back to the nodes using LoRa, and then the nodes can generate data and send the data to that gateway, which is the data gateway. So we also have a FWOTA server here, which is an optional service where we can update the nodes over Wi-Fi, over a public Wi-Fi, so we don't have to go and install a new firmware one by one, just to save time. So, okay, I'm going straight forward to the demonstration. So what you can see here, apart from the two windows with the nodes and the gateways, we can see four other windows, command line windows. Here in where we send the initialization command from the Raspberry Pi, here is the command that is received by the initialization gateway and then is broadcasted to the nodes. This is the output of one of the nodes, and this is the output of the data gateway using spreading factor 7 in this experiment. So I will just initiate an experiment. Actually, I have already done it, pre-recorded. using 20 packets. So I will request from the nodes to send 20 packets, and then when they finish, they will report some statistics to the statistics gateway, so we can see the statistics here. So once the broadcast packet received by the nodes, we can see that the LED will turn blue. Here you go. So they turn blue, and then they start the process of registering to the gateway one by one at random times, actually. This is because the registration is an LoRa based approach, so we don't have slots yet. So this is the output of one of the nodes, so we send the request here, and then we get back the device address, and which is translated to slot 0 in that example, which is the first slot actually. And that node then is waiting for the first synchronization from the gateway here. So one by one, all the nodes will register, and they will start to transmit packets. We can see here 2 nodes already transmitting packets, and I will go just a little bit fast forward to save time. So we can see here that we have received 3 packets from nodes 34, 30, and 35. This is the ID of the nodes and some information about the RSSI, SNR, the spreading factor, etc. And on the other hand, we can see the output of the node, which is actually some information about the frame, the timings of the frame, and how many packets were transmitted so far, delivered so far, retransmitted and dropped. So once all the nodes transmit 20 packets, this is a periodic process actually, and you can see here that when the LED of the nodes is off, this means that the nodes are in low power mode. When it turns white, it means that they are in the receiving mode to receive the SAC packet, the synchronization and acknowledgement. And when the LED turns red, this means that the nodes transmit. Okay, the transmission is very fast, so you cannot easily see it, but I have another slow motion video later to show you the slots. So I'm going to the end of the video to show you the statistics. So as you can see here, 2 nodes have already the third node, the third one has sent out the statistics as well. So we have 3 nodes already sending their statistics. So we can see that 20 packets were transmitted from each node, and 20 were acknowledged. So we have 100% packet delivery ratio in this experiment. And when the experiment finishes, actually the nodes go back to the initial state, so we can initiate another experiment from the beginning. And I will show you also the slow motion slide. You can see here what I told you about the white LED and the red. So if you see carefully, this is the first slot, slot 0. This is the second, and this is the third. So the nodes transmit in that order because they have got actually these slots from the network server. Okay, this is what I wanted to show you. Thank you for your attention. If you have any questions, happy to answer, or you can drop me an email to this address. You can also download the source code and test it, the TS LoRa code, and test it on your PyCom devices. Thank you again. See you soon.